Welcome to MRL. In this learning session, we will learn the solutions of the examples of end of chapters exercises of Ganita Manjari 9th standard CBSE textbook. This particular video is the second part of the study of the solutions, and in the first part we have already learnt the solutions of 9 examples, and here in the second part we will learn the solutions from 10th example onwards. Now in the 10th example we are given a line segment AB. The coordinates of A are 3 minus 4, coordinates of B are xy, and there is a midpoint of AB, that is m minus 7 1, whose coordinates are already given to us. Now we have to find out the coordinates of the end point B, that is the coordinates x and y has to be found out. Now here, to find out bxy, we have to apply the midpoint formula, and we know that the x and y coordinates of the midpoint can be found out by taking the average of the x coordinates of A and B and the y coordinates, average of y coordinates of A and B. So let us apply the midpoint formula and then equate them. Now minus 7, if you take x, here it will be the average of the x values of x values of A and B. Therefore it is 3 plus x divided by 2. That means minus 7 is equal to 3 plus x divided by 2, and that is 3 plus x is equal to minus 14, x is equal to minus 14 minus 3, and x is equal to minus 17. Same way, 1, that is the y value of the midpoint, is equal to the average of the y values of A and B. Therefore minus 4 plus 5 by 2, minus 4 plus 5 by 2 is equal to 1, and simplifying that we get y is equal to 6, and therefore the coordinates of bxy are minus 17 and 6. A very simple example, but it's a good example to solve and to be asked in any examination. Now coming to the next example, that is the 11th example, we are given PQ, the points. The PQ are the points of trisection of line AB, where A 4 7 and B 16 minus 2 are the coordinates of A and B. So let us understand what is the meaning of this. We are given a line segment AB. The coordinates of A are 4 7 and B are 16 minus 2, and there are two more points marked on the line segment AB, that is P and Q. And now we have to find out, and we have to find the coordinates of P and the coordinates of Q. But the coordinates of P and Q are such that the AP is equal to PQ is equal to BQ. That means these 2 points trisect or divide the line segment AB into 3 equal parts. That is what I have shown here. AP is equal to PQ is equal to QB. Now we have to find out the coordinates of P and Q. Now to find these coordinates, there are 4 unknowns here, x1, y1, x2, y2, 4 unknowns are there, and to find 4 unknowns we have to get 4 equations, and for that what I will do is I will apply midpoint formula for P taking AQ as the line segment, and for Q taking the line segment as a PB. So let us see how to do it. Now Px1 y1 is the midpoint of the coordinate points AQ. The coordinates are 4 7 and x2 by 2. So applying that, we get x1 is equal to 4 plus x2 divided by 2. That means 2x1 is equal to 4 plus x2. Similarly, y1 is equal to 7 plus y2, 7 plus y2 by 2, and therefore 2y1 is equal to 7 plus y2. Same way for point Q, x2 y2, we get Q x1 y1 and B 16 minus 2 are the coordinates given to us, and to find out x2, I have to add x1 and 16 and divide by 2, x1 plus 16 by 2. That means 2x2 is equal to x1 plus 16. Same way, y2 is equal to y1 and minus 2 divided by 2. Therefore 2y2 is equal to y1 minus 2. So by applying the midpoint formula 4 times, I have got 4 equations, and 4 equations are necessary for finding out the 4 unknowns. So now let us solve these 4 equations and get the 4 unknowns. Let us begin. Now take the first equation. That is 2x1 is equal to 4 plus x2, and put the value of x2 from equation number 3. That is x1 plus 16 divided by 2. I have put the value of x2 here, and by simplification and further simplification, I get x1 is equal to 8. It is a very simple simplification. I think you can follow that. X1 is equal to 8. Now coming to the again 2x1 is equal to 4 plus x2, put the value of x1 here, that is 2 into 8 is equal to 4 plus x2, therefore 16 is equal to 4 plus x2, x2 is equal to 16 minus 4, and we got x2 as 12. So we got the values of x1 and x2. Now let us go for finding out y1 and y2. Now 2y1, see it is given here, 2y1 plus 2y1 is equal to 7 plus y2. Now y2 value we get from here, so we get y2 is equal to y1 minus 2 divided by 2, substitute here and simplify, we get y1 is equal to 4. Now what you do is put the value of y1 is equal to 4 in 2y1 is equal to 7 plus y2, we get the value of y2, that is 1. So we have got x1, x2, y1, y2. So therefore the coordinates of P are 8, 4. The coordinates of P are 8, 4, and the coordinates of Q are 12 and 1. So 12 and 1. So that is how we have found out the coordinates of the points P and Q, which divide a given line segment into 3 equal parts. Okay, remember that. So that is the method. Now coming to the next example, we are given a rather 3 points here, A 1 minus 8, B minus 4, 7, and C minus 7 minus 4. Now what we have to show that is the points A, B and C lie on a circle, they are concyclic, and also with concyclic lie on a circle with the origin, the circle K is given with the origin as a center, 0, 0 are the coordinates of the center. Now we have to show that A, B, C lie on the circle, and also we have to find out the radius of the circle. Now if K is a circle with the center OO, with center of the circle as coordinates 0, 0, OA, OB and OC are joined, I can join OA, OB, OC, and they are nothing but the radii. Now if I show that OA is equal to OB is equal to OC, it means that all the 3 lines, the 3 points lie on the circle, A, B and C lie on the circle. So now let us find out, again apply the distance formula here. Now if I have to find out OA, then it is 1 minus 0, that is 1 square, 8 minus 0, that is 8 square, so therefore it will be root of 1 plus 64, that is equal to root of 65. Now find out OB, again applying distance formula, we get 0 minus of minus 4 is 4 square, 0 minus 7 minus 7, that is 7 square, so 4 square plus 7 square is equal to 16 plus 49, and that is root 65 again. Now to find OC, again 0 minus of minus 7 is 7 square, 0 minus of minus 4 is plus 4, that is 4 square, 7 square plus 4 square, again root 65. Therefore we have the radii all equal, OA is equal to OB is equal to OC, that means the points ABC lie on the circle. And the second part is what is the radius of circle, but natural, OA is the radius, OB is the radius, OC is the radius, therefore radius is root of 65 units. Please remember that. Now one more very important part of the same question, that is second part, we are given 2 coordinate points, that is D minus 5, 6 and E 0, 9. We have to find out whether these points lie inside the circle or outside the circle. So let us understand this. Now let us find the distance OD and OE. When I find the distance OD by applying distance formula, I find that it is 0 minus 5 0 minus of minus 5, that is 5 square, 6 minus 0 is 6 square because the center is 0, 0, so I get root 61, and OE will be root of 0 minus 0 is 0 square, 9 minus 0 is 9 square, again I get the value of 9 here, or root of 81. Now you find root of 61 is less than root 65. Root 65 is the radius, that means 100% root 61 is less than root 65, therefore the point D lies inside the circle. Root 81 is greater than root 65, therefore the point E lies outside the circle. So try to understand that. Now coming to the next example, we are given a triangle ABC, and D, E, F are the midpoints of the sides AB, BC and AC, and the coordinates are given as D is 5, 1, E is 6, 5, F is 0, 3. Now we have to go to find the coordinates of A, B and C. Now I have assumed here the coordinates of A as x1, y1, B as x2, y2 and C as x3, y3. Now if you observe, there are 2 unknowns here, there are 2 unknowns here, there are 2 unknowns, there are total 6 unknowns here. That means we have to get 6 equations to find out these 6 unknowns or 6 values. Now let us see how to do that. I have to apply the midpoint formula for AB, midpoint formula for BC, midpoint formula for AC. So let us apply the midpoint formula for each of the sides. Now if I take AB, then 5 is equal to x1 plus x2 divided by 2, that's what I have done here, or x1 plus x2 is equal to 10. Now y1, then there is 1 is equal to y1 plus y2 divided by 2, and therefore y1 plus y2 is equal to 2. Similarly, I have to apply the midpoint formula for side BC and for side AC, and that's what I have done here. Now 6 is equal to x2 plus x3 divided by 2, therefore x2 plus x3 is equal to 12, y2 plus y3 by 2 is equal to 5, and y2 plus y3 is equal to 10, x1 plus x3 divided by 2 is equal to 0, x1 plus x3 is equal to 0, y1 plus y3 divided by 2 is equal to 3, y1 plus y3 is equal to 6, because multiplying 2 here. So I have got 6 equations. So first, second, third, fourth, fifth, 6 equations I have got. Now I have to solve these 6 equations to get those 6 unknowns. So let us go step by step. Now let us go for the first equation, or okay, let us see how to get the values. Now let us take the equation number 1, that is 1 here, x1 plus x2 is equal to 10, and add to 5. x1 plus x2 is equal to 10 and x1 plus x3 is equal to 0. When I add, x1 plus x1 becomes 2x1, and plus x2 plus x3 becomes 6 plus 10. That is, here I have got 10 here, and I have got 0 here, so 10 plus 0 is 10. Now 2x1, but we have got x2 plus x3. x2 plus x3 is 12. So I put the value of x2 plus x3 here. So 2x1 plus 12 is equal to 10. 2x1 is equal to 10 minus 12. 2x1 is equal to minus 2. Therefore, x1 is equal to minus 1. So we have got the value of x1. In the same manner, we have to go further. Now once I get x1 is equal to minus 1, we know that x1 plus x3 equal to 0. Already you know that. x1 plus x3 equal to 0. So put the value of x1 in that. Minus 1 plus x3 equal to 0. Therefore, x3 is equal to 1. Now also we know x1 plus x2 is equal to 10. Now put the value of x1 again, we get the value of x2. So we have got x1, x2 and x3. Now let us go for finding out the value of y1, y2, y3. Now take equation number 6. Equation number 6 is y1 plus y3 and also y1 plus y2. So y1 plus y1 becomes 2y1. y2 plus y3, plus y2 plus y3, 6 plus 2 is 8. So that's what I have done here. I have got 8 here. Now simplify this, you will get y1 is equal to minus 1, because y2 plus y3 value is already known to us. y2 plus y3 is 10. So I have put the value of y2 plus y3 there as 10, and I have got the value of y1 as minus 1. But we know that y1 plus y3 is equal to 6. So y1 is minus 1 plus y3 is equal to 6. Therefore y3 is equal to 7. I have got the value of y3. Now y1 plus y2 is equal to 2 is also known to us. Put the value of y1 here minus 1 and find out the y2, and the value of y2 is 3. So we have got all the values of x1, x2, x3, y1, y2, y3. Therefore we can find out the coordinates of the vertices of the triangle ABC. The coordinates of A are minus 1, B is 11, 3 and C is 1 and 7. So that is what is the method of solving this example. It is slightly lengthy, or definitely lengthy, but easy if you understand the method and the procedure. Okay, learn that. Now coming to the next example, the 14th example. Here this is a very interesting example. Now there is a city center, and through the city center there are two roads, one moving from south to north or north to south. That is the main road, and also there is another main road from west to east or east to west. Now to these two roads there are 10 parallel roads at 200 meters each. There is 200 meters gap, so there are 10 roads parallel to this main road, vertical road, that is the south north road, and also there are 10 parallel roads to east west main road. Now they have given that one of the roads, vertical road and the horizontal road, intersect each other, and the coordinates of their intersection is P25. That is given. P25 is given to us. P25 means what? P2 is the x coordinate of that point, and y is the phi is the y coordinate. So we have got P25. Now the question asked is are there intersections of roads with the coordinates as 3, 4 and 4, 3? Definitely they are there, because we have got 3 and 4. So if you observe here, we have 3 and the 4. So we have one intersection as Q34 and another intersection as R43. Now are these distinct? Definitely they are distinct, because 3, 4 is not equal to 4, 3, and therefore they are 100% distinct intersections. That's what I mentioned here. One street intersection can be referred to as 4, 3. I can refer it as 4, 3, and another street intersection can be referred to as 3, 4, and they exist there. And these three intersections are 100% distinct intersections. So this is what is the example, and these are the questions, and the questions are answered, and the diagram is very clear. So go through, understand the diagram, understand the answers given to you, and learn, remember, and learn that. Now coming to the next example, we are given a display screen. There is a screen here, and the horizontal pixels of the screen are 800 pixels and the vertical pixels are 600 pixels. Now I have taken a scale here. 2 centimeters is equal to 100 pixels. So therefore I have got 100, 200, 300. Horizontal pixels are 800 and the vertical pixels are 600 as with the same scale. That's why the scale is 2 centimeters equal to 100 pixels. Now there are two circles drawn on the screen, they are rather displayed on the screen. Now the first circle is C1 is of radius 80 pixels and the second circle C2 is of 100 pixels. So both the circles are drawn on the screen because the coordinates are given to us. The coordinates A 100, 150 is the center of first circle and the coordinates of B, that is 200, 230 is the center of the second circle. So with this center and the radius 80 pixels, with this center B and the 100 pixels as the radius of the second circle, the circles are drawn and we find that both the circles are within the screen. They are not out, none of the circles have gone outside the screen. They are within the screen, and that is the question asked, whether they are within the screen. Definitely they are within the screen. And also the question asked is whether they intersect. Definitely they are intersecting, and they intersect at 2 points P and Q. They are intersecting circles. They are not touching circles but intersecting circles because they intersect at 2 distinct points P and Q. That's what I have written here. Two circles C1 and C2 of radii 80 pixels and 100 pixels are displayed. The circles are displayed within the screen fully, and the circles intersect at P and Q, and C1 and C2 are therefore intersecting circles. And these are the questions asked and the answered, and also the graph is drawn in front of you, which is very clearly visible and explains everything. All the questions are explained. Now coming to the next example, that is example number 16. Here the coordinates, 4 coordinates are given, that is A2 1, B minus 1 2, C minus 2 minus 1 and D 1 minus 2. We have to locate these coordinates on a graph paper and join the coordinate points, that is AB, BC, CD and D are joined, and we get a quadrilateral. Now the question is this quadrilateral a square? Is this quadrilateral a square? Yes, it appears to be a square, but we have to verify whether it is a square or not, or we have to confirm whether it is a square or not. Now to confirm whether this ABCD is a square or not, the method is very simple. Find the distances AB, BC, CD and DA. If all the distances are equal, all the 4 sides are equal, 100% it can be a square or it can be a rhombus. We do not know. So if it then further, find out the diagonal's length, that is find out AC and BD. If AC and BD are also equal, 100% it will be a square. So the one possibility is it can be a rhombus. The second possibility is it can be a square. If all the 4 sides are equal, it can be a rhombus also. And the best thing to do is find out the length AC and BD. Of course, we can find by another method also. We can find out whether angle D is 90 degrees, and that is also possible by applying the Pythagoras theorem. We can go for finding out whether angle AD is. For that, we have to find the diagonal AC. Once we find diagonal AC, we can verify by Pythagoras theorem whether AC square is equal to CD square plus AD square. But we will not do that. We will go for finding out the 2 diagonals and confirm it. Now let us go for finding out the lengths and the diagonals. Now the coordinates given are A2 1, B minus 1 2, C minus 2 minus 1 and D 1 minus 2. If to find if ABCD is a square and why it is a square, and to find the area of the square ABCD. Now the points ABCD are plotted on the graph and it appears to be a square, that I have told you. Now to confirm ABCD is a square, we have to show all the sides are equal, that is AB is equal to BC is equal to CD is equal to DA, and also the diagonals are equal, that is AC equal to BD. So we have to find out the distances, and I have found out AB here, BC here. So I have found out just the distance formula, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Apply that and we get root 10 here, and BC is also root 10, CD is also root 10, DA is also root 10, and the diagonals AC is equal to root 20, BD is equal to root 20. Because we know all these values, we can find out the distances. Now we have confirmed that the 4 sides are equal, that is AB is equal to BC is equal to CD is equal to DA is equal to root 10 units, and also we have confirmed that the diagonals AC is equal to BD is equal to root 20 units. That means the diagonals are equal. Since I have all the 4 sides equal and the diagonals equal, the quadrilateral ABCD is a square, and that is confirmed. Okay, that is a square. Now the second part is to find the area of a square. Now you know that the area of a square is a side square, side whole raised to square, and that is equal to root 10, because one side is root 10 and the area will be root 10 square, and that is 10 square units. So that is what is these are the solutions of the examples of end of the chapters exercise of the units, coordinate geometry, or use of coordinates chapter of Ganita Manjari, a 9th standard CBSE textbook. So that concludes this particular chapter. So please go through all the basics of this chapter. There are videos which are there which will help you to learn the basics, and then apply that knowledge to solve these examples. Some examples are definitely typical, but otherwise the procedure, the method are simple. Learn them and note down everything in a book where you can refer them in your future. There will be a reference for future for you. So learn them. Okay, thank you.